Welcome back to chemistry. We are still going to be doing some of our grade 9 chemistry review. And so this is module number 11 and the topic is atoms and ions. So I'm hoping that you had a good chance to go through the periodic table and add some of the summary things to the periodic table. Again, this is from my solution set, so feel free to add a few things to here if you didn't already. You'll notice there are a few extra things that I've got onto this periodic table because we'll keep coming back to it and building as we start learning about things. You'll see that I've got some charges on here. Some of them you know about and some of them you might not know yet, but go ahead and complete that for now. And let's see if you remember how to do Bohr-Rutherford diagrams, how to make an atom into an ion. And we'll start though with our subatomic particles of the atom, okay? So the one thing that I want you just to think about for this module and as we move through chemistry is that everything we learn in chemistry builds. So you really have to be able to understand this topic before we move on to the next topic, okay? So make sure you do your homework questions and you understand it because all of a sudden it's going to start going fairly quickly once we start moving into the grade 10 content, which is all about naming compounds. So in order to be able to name compounds, which is basically what a molecule is when you start reacting metals and nonmetals together or nonmetals and nonmetals together, there are some rules for that, and all of the rules are based on the type of atom that you've got and the electrons, how they're arranged, and especially those valence electrons, okay? Because it's the valence electrons that determine how that particular atom reacts with another atom or how it becomes an ion, okay? So you really want to see if you make sure you understand this concept. So I'm going to go through, I think, for this module to kind of make it not forever too long. I want to just maybe highlight using my solution set. So again, if you have access to a printer and you can print some notes, that's great, you're lucky. And if you don't, that's okay. Just make a little summary in your own handwriting, and those of you who've been working on your summaries, I've been able to see that they're looking really good, okay? So just keep it up, just make it nice and neat and organized, give yourself headers and subheaders, make a reference to the topic in the textbook where it is, and go ahead and do some homework questions. Remember that this module should take about an hour and a half, so plan your time accordingly and do as many or as few answer questions as you'd like to. Okay? All right, so here we go. PEN, that's your acronym. An acronym is taking out little letters from all of the things you need to remember and associating something with each letter that you've got in that little acronym. So P stands for proton. We remember that protons are positive. They both start with the letter P. That should be easy. An electron is a negatively charged particle, and a neutron has no charge. When you're looking at the overall mass of an atom, any atom, relative to each other, the protons and neutrons are both about 1 atomic mass units. Electrons have absolutely no mass because they are more like a charged part of it, which has just kind of floating around and buzzing around the nucleus. And they, relative to the other ones, they're essentially zero, okay? What does that mean? It means that the entire mass of the atom has to do with what's inside of the nucleus. And the nucleus is a very dense structure inside of the atom. It's positively charged because of the protons. The neutrons have no charge, and it's the electrons that are buzzing around outside in the orbitals or the shells, we call them any which way. Those are where the electrons are found, and does it make sense that when you have opposites, they're going to attract each other? Here's an example, right? Electrons are negative, the protons are positive, positive and negatives attract, and that's basically what holds them into place, okay? So a couple of things to take away from here. Protons and the number of them, that's what determines the kind of element. It never changes, okay? Every single time you're talking about something with 10 protons, for example, that is atomic number 10, that's neon on your periodic table. Every single time we're talking about oxygen, oxygen has 8 protons in its nucleus. Its atomic number is 8. It has the same number of protons and electrons because they're going to be balanced with each other. That's a neutral atom. The only thing that can change is the number of neutrons, and they can vary, and that's something called an isotope. So you'll learn about that in grade 11. Electrons is what come and go from an atom. That's what makes an ion, right? An ion is an atom, but an atom with a charge to it. Okay? Atoms can gain electrons, atoms can lose electrons. It all depends on how best to make that atom stable. Of course, there are trends from the periodic table that are going to help you figure that out, okay? The metals, which are on the left-hand side of your periodic table, they tend to like to lose electrons. And if you get rid of something that has a negative charge, you're going to have an overall positive charge. The non-metals on the right-hand side of the periodic table, sorry, on your diagram we're looking this way, yeah. All of your nonmetals, they like to gain electrons. And if you gain something that's negative, now you have a negative charge, okay? So whether you gain or lose something, you're only gain or losing the electrons, okay? Static charge, you learned that in grade 9. You rub something onto another object, you're losing the electrons. You are never losing the protons. So those electrons can get picked up by certain objects and have a charge to them. They can leave a certain object. They can also have a charge, okay? Positive or negatives, that's the charge. Atoms are very small, and of course, they're the building block of molecules. They make up everything, right? All things that are matter are made up with all of the elements on the periodic table. Okay, that's our subatomic particles. Moving on, let's see if we remember from grade 9 how to make a Bohr-Rutherford diagram, okay? Follow very carefully the rules. First energy level can hold a maximum of 2 electrons. The next energy level can hold a maximum of 8 electrons. Okay, this rule only follows for a certain number of atoms on the periodic table, because then you know what, the rules will change. The rules change once an atom becomes too big. Then those electrons don't follow the normal rules. We'll learn about the next rule when we get to grade 11. But for now, we're only going to do the Bohr-Rutherford diagrams for a certain number of atoms on the periodic table, because that's all it's going to make sense, okay? Those are your rules. Energy level number 1, that's the first place where electrons are found, holds 2 electrons. The next energy level can hold a maximum of 8 electrons. And all atoms start by filling up energy level number 1 first, and then energy level number 2, and energy level number 3. Okay, do you remember where they are on the periodic table? The rows or the periods on the periodic table tell you how many occupied energy levels each of those atoms have. So all atoms in row number 1 only have 1 occupied energy level. That's energy level number 1. Row number 2 only have 2 occupied energy levels. Energy level number 1 is filled, and then you fill up energy level number 2. Okay, and does that make sense? Because by the time you get to the end of row number 2, you're at number 10. 2 electrons in energy level number 1 plus 8 electrons in energy level number 2. That's full. That energy level is completely filled. You're at the end of the periodic table. You would move to the next one. Okay, so you use your periodic table to help you even remember some of those rules. All right, here we go. How do you figure out the numbers? You did this in grade 9, so I'm going to let you just do this quickly. Okay, how many protons, electrons, and neutrons? Take an average of the atomic mass, round it to the nearest whole number, please. Okay, why? Because there's an average different number of neutrons. You take an average of them and make that a whole number. Number of protons will always be a whole number. It is the atomic number. Okay, so what do? You're going to show the number of protons and neutrons in the nucleus of the atom. There we go. And we're drawing this for potassium, right? So 19 protons, 20 neutrons. Energy level number 1 has 2 electrons. Once it's filled, you move on to energy level number 2. It's filled with 8 electrons, okay? 2 electrons, then 8, and then 1. So 2 plus 8 plus 8 plus 1 is going to give you 19. You now have a total of 19 electrons. Remember, the number of protons equals the number of electrons because you have a neutral atom. Okay, what do? We need to remember now that this outer shell is called our valence shell. That is the outer shell. And every atom in group number 1 will have one valence electron. Okay, one valence electron means that that atom is going to be stable by turning into an ion by losing that one electron. So then its outer shell, which would be this one, would now be full. It's easier to lose one electron from this valence shell than it is to gain 7. That's why potassium, like all other metals, want to lose electrons, and by losing electrons, they become a positive ion. Do you remember the name of a positive ion? It's called a cation. Negative ions are anions, okay? All right, you're gonna skip from here to doing the Bohr-Rutherford diagrams. Again, do as many or as few as you need to, okay? What do you see in the trend? You wanna see that every single element in group number 1 all have one valence electrons because the group number tells you how many valence electrons you have. You need to be able to know this so that then you can decide and determine how this type of atom is going to react with another one, because it's all about the valence electrons. Okay, everything in group number 2 has 2 valence electrons. How do you show that? You can do a little Lewis dot structure where you show one electron on this side, one electron on this side. They would be far away from each other because they have the same charge. If you're in group number 3, you have 3 valence electrons. Okay, there's boron, etc. Feel free to do as many of these as you'd like. Okay, pause here. I would do all the work for Bohr-Rutherford diagrams, and then I'd come back and do the second part, which is going to be on our how do atoms make ions.